In this chapter, we will be exploring exponential functions. In this lesson, we will be looking at exponential regression.
Okay, so sometimes in these questions, what you're presented with is not the equation that models the data that you're looking at. You're actually given the data, the raw data here. And so if that data follows some sort of a pattern, be it what we call linear here, quadratic, exponential, logarithmic, trigonometric, whatever, okay, what we do is we use regression, okay, to find a line that fits it the best here, okay? Now, this is very similar to what you would have done in the past with what you call a line of best fit, where you pulled out your ruler and you kind of eyeballed it there. The problem with eyeballing it is that not everybody's going to come up with the same equation or the same line based on exactly the same data. Okay, it just depends on how you eyeball it. So what we've done is we've come up with some methods of determining lines that fit the data the best we can, but at least they're consistent. Okay, so everybody's kind of using the same thing here, and that they've been programmed into the calculator so we can access those. So what we're going to do here is we're going to follow along the steps here and just see how this works. So we're going to pull out our graphic calculator and we're going to do an exponential regression here. So we're going to look at some data that has an exponential relationship to it, and we're going to let the calculator model it. So here we go. So first of all, what we're going to do is we're going to follow what it says right here, and we're going to press stat. Now there's our stat button right there. Okay, so we're going to press stat. That's going to take us to this screen right here that you can see, and we're going to go in and edit. We're going to press enter on edit. Now that takes us into our lists here, and what we're going to do is we're going to enter in the data, and we'll enter the data that we see here. So this first column here, L1, is 0, 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5. Okay, you got to press enter after every one. Then we'll use the right arrow to move over. And now it's 70, enter 76, enter 84, enter 92, enter 101, enter 111. Okay, so we've entered our data in. Good. Data's all in there. Now, if you ever want to get rid of your data, when you want to clear the list here, what you do is you go up to the very top, you go up to the name, and then you would press clear and enter. Clear and enter. If you do that, it'll get rid of all the data. Don't just press delete. That actually gets rid of the entire column. Now it doesn't actually get rid of it, it just doesn't show it. It stops showing it. It's still there, but they won't show it to you. Anyway, for right now we just want to talk about getting this regression done here. So there's our data here. Now, the next thing that we're going to do, okay, I would quit out of this. I would go right back to the home screen, because there's some of the older calculators have a hard time if you try to attempt this from that screen here. So we're here. We're going to press stat again, and this time we're going to go over to the calc menu. And right here, now the top part here, this is a little different, but from about number 3 down, these are all different types of regression calculations that the calculator can do, and it can do a lot. Okay, what we're interested in is we want to go down. We're looking for the EXP reg, exponential regression right there. So that's numbered 0 here. So we're going to press enter. Now my calculator does it like this. Not every calculator does it like this. Some calculators, what you got to do here is you have to you would enter list 1 comma list 2, so that the calculator knew that the list 1 was the x coordinates, list 2 was the y coordinates. Now I'll show you where to get list 1 and list 2. If you press second number 1, there's your list 1. Second number 2, there's your list 2. So those are the two variables here. And your comma, by the way, the comma button, because you have to put a comma in between those, is right above the 7. There's your comma button. For my calculator, I don't need to do that. I've identified the list. It's already identified list 1, list 2, and I'm just going to go down to calculate. And here we go. So the calculator gives me the form of the equation, AB to the x, and it tells me that A is 69.68, blah, 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 and B is 1.097, so on and so forth. Now, my calculator is also giving me these R values here, R squared and R. What those are regression coefficients. The closer R is to 1, okay, the better my regression is at capturing the data. Okay, if it was 1, then this would be a perfect regression. It's not 1. It's very close to 1, but it's not 1. So it's not a perfect regression, but it's pretty darn good. Now, I'd like to be able to see this. Okay, I would like to be able to have this thing graphed here. Don't go through and copy this down on a piece of paper and then try to enter it in the calculator. The calculator stores everything that you do. So what we're going to do here, and it's described for you right here, we're going to have the calculator drop this equation into y1 so that we can graph it. And this is how you do that. First of all, we're going to press y1, or sorry, y equals, so that we're sitting here at y1. Okay? Now, what we're going to do here is we're going to press vars. Okay, so vars is over here. And by the way, this is a button that I think is highly underutilized. I think more people should understand what this does here. Vars. Okay, now it opens up a list here of different things that the calculator stores in variables. Now we want to go over to we want to go over to number 5, statistics. Sorry, because what we just did was a statistical thing. When you deal with lists and you do regressions, that's a statistical analysis. So we're going to go to number 5. And what we're looking for is the equation. So we're going to go over the equation. And the very first thing you've got here, the very first quote-unquote variable that it's got here is regeq. Okay, regression equation. So just press enter there. And then what that does is it copies down as much as it can remember of that regression equation. So now we've put the regression equation inside the calculator. We're going to graph this in just a second here. Okay. Now, before we graph it though, what I'm going to do here is I'm going to go back to my main screen here. To graph it, we want the window settings to reflect what the data is there. So now I might go to my window, or my zoom, and go down to zoom number 9, zoom statistics. Now you'll notice nothing happened there, because what I got to do here, and I do that on purpose here so that you see that some of those zoom features there don't really work unless you give it a little bit of aid there. So let's quit here. What I got to do is I got to go and enter my stat plot. I have to turn something on here. So I'm going to press second y equals. Because what I entered in was a set of data, what I got to do is I have to let the calculator know to look at the data. So we're going to go into our plot 1. It doesn't matter which of these plots you go into, but just go into plot 1. And we're going to turn it on. Now, what I should have here is I should have probably scatter plot highlighted, because I'm going to get the calculator to draw the dots there. My X list is list 1. My Y list is list 2. Okay, I want it looking in those spots there. So if those are different there, then please go in and change those. From this point, and it doesn't really matter what the rest of it is, this is just your personal preference. You can play with those settings. But this should be scatter plot. This should be list 1. This should be list 2. Now if I press zoom and go down to number 9 for zoom statistics, now the calculator chooses a window settings such that I can see all of my data. And because I put the regression equation in y1, it graphs my regression equation on top of that data there. Awesome. Excellent. So now you've got a bit of an example as to how to do a regression, how to get the equation, how to graph it. Okay. Now a couple other things that you should know about the regression here. Okay. When you do an exponential regression here and you're asked for the growth rate, okay, that represents the rate of increase or decrease of the population of whatever it is that you're modeling here. I'm going to zoom out just a little bit here. The easiest way to do that is to look at your B value here. Now, if B is greater than 1, we've seen before that represents growth. It's increasing, okay? If B is between 0 and 1, we know that it's decreasing. But the approach to see what the percentage increase is, or the rate of growth, or the rate of decay, if you will, we do the exact same thing. We're going to take the B value, and just like it says right here, we're going to subtract 1. We're going to subtract 1. Okay? And that's going to give me the rate of increase. So if you've got like a 5% growth or like a 10% decay sort of thing, we're losing 10% here. You always do it by taking the B value and subtracting 1. Now let's take a look at some examples down here. So in this first example here, okay, look at our function here. We've got 2,000 times 1.03 to the x. Now, there's my B value. Notice it's greater than 1, so it's growing. So we're going to take 1.03, we're going to subtract 1 from it, we're going to get 0.03. that indicates a 3% growth. It's 3% more than 1. Okay, let's take a look at this next one here. We got, it doesn't really matter what this coefficient here is, what is that, 1050 times 1.025. Our B value is 1.025. Let's subtract 1 from that and we get 0.025. That corresponds to a 2.5% increase in the data. Okay, whatever the population is, it's 2.5% larger than 1. Over here, we'll do the exact same thing, just in the opposite direction. So we got 2,000 times 0.98. Now notice that this is less than 1, so this is going to be decreasing. So 0.98 minus 1, and we're going to get negative 0.02. This represents a decrease or a loss, that's the negative, of how much? 2%. Okay? Down here, we've got 1050 times 0.8 to the x. Okay? So there's our B value. We're going to take 0.8, we're going to subtract 1 from it, and we're going to get negative 0.2. And this represents a loss, now this is a bigger loss here, of 20%. A depreciation of 20%. Okay? So it's the same approach every time. It's just, okay, it's just the values here, depending on whether you've got growth or decay, you're either going to get positive or negative. Obviously negative meaning decay, positive meaning growth, and you just convert the decimal, the fraction you've got, to a percentage.
For each table of values, identify if it is exponential growth or exponential decay, and determine exponential regression equations and the rate of increase and decrease.
Okay, so for this question right here, the first thing we're going to do is enter in the data that we're given. Okay, so again, we press Stat, okay, to get into our statistics menu, and we're going to go and press Edit or enter Edit. Now, I've already got data in here from a previous example that we did, and I'm going to clear out some data here. Now, first of all, I want to redo the entire list too, the Y list here. So I'm going to arrow up to the name of the list, and then I'll press Clear. Now, when I do that, the calculator's waiting because it's essentially asking, are you sure you want to clear? And then just press Enter and watch what happens. It deletes all the data there. Okay, so now I'm ready to plug in all of my data here for the second list. Now, notice in the first list, that's all basically the same, except I don't need the 0 there anymore. There's no 0. So you can also do this. If I move over and highlight the one that I don't want, I can then press Delete, and that'll get rid of that particular value in the list. Okay, so now I'm going to enter in the Y column. So 6, enter, 18, enter, 2, enter, and 486. Okay, so there's my data. And now I will quit. And now to do the regression, what I'll do is I'll press Stat again. We go over to the Calc menu, and we're looking for the exponential regression, and there it is at 0. It's exponential regression. Now remember, you might have to enter in list 1, comma, list 2. Okay, list 1 is above the 1, list 2 is above the 2, and the comma is the button right here above the 7. Unless you've got the calculator like I've got, this operating system, in which case you just press Enter, Enter, go down to Calculate, and here we go. So now the equation is given to us, and now we can enter in these pieces here. So first of all, they want to know what the regression equation is. Well, AB to the x, A is 2, and then this will become 3 to the x. Now notice my R value here is 1. That means this is a perfect exponential regression. Again, we can see that with the equation here. It's asking for the value of B. We got 3. Is this growth or decay? Well, this will be growth because the value of the base is greater than 1. So this graph is going to be moving upwards as we move to the right here. The value of A is 2. And think about the pattern that we've already established in a previous lesson here. A and the y-intercept are going to be the same. So the value of the y-intercept is going to be 2. There we go. Okay, so this one's very similar to the previous one that we just did. Again, we've got our data here, so we'll press Stat. choose enter on edit to go in. And now we're going to get rid of the second list here. I don't have to edit anything on my first list. All of the numbers are there, 1, 2, 3, 4, 5, that's good. So we go up to the top, and again we press clear, and then enter to eliminate that second list there. So now I can enter the numbers as I see them, 200, 100, 50, 25, 12.5. Okay, now I'll quit. And again, to get our regression, I will press Stat, take us to this menu, over to the Calc menu, and then we go down to Exponential Regression. List 1, comma, list 2. And so now the calculator is going to find the line of best fit, assuming this is X and this is Y. All right, so AB to the X, if A is 400, and B is 0.5, or a half. Good. Okay, so now we can answer the rest of these questions. This first one here is asking for the value of B, and so that was a half, which means this is decay. Now, I didn't really need to go to my equation to know that this was decay. Look at the values here, 200, 150, like it's getting smaller. This is a decay function. The value of A is going to be 400, which means I would expect that the y-intercept here is also going to be 400, because that's just the way those properties work. A is the y-intercept. There you go.
Use the following table to answer the questions below about the value of a ring.
All right, so to answer this question, the first thing we're going to do is perform a regression on the table that we've got. So, pull out my calculator here, and we will press Stat, Edit. Now I've got 2 lists of data here already, but neither one of those is going to be fit this data. So I'll move up, press Clear, and then Enter. Move up, Clear, and then Enter. For my set of X coordinates here, I've got 0, 1, 2, 3. Okay, so that's going to be pretty easy. 0, 1, 2, 3. Oops, 3. Now over to the Y coordinate. 9,600, 9,960, 10,344, 10,752. Okay, so now I can tell by looking at that, because of the way the data is going, this is obviously a growth function here. But we'll see that proved in just a second. We're going to get out of there, press Stat, over to Calc to do the regression, and again we're going down to Exponential Regression. List 1, comma, list 2. Okay, so here we go. So we're being asked for the exponential regression equation to the nearest 10th. Okay, so let's see if we can pull this out here. So it's AB to the X, where A is 9595.4, whoops, times our B value is 1.0. Now I'm supposed to be doing these to the nearest 10th. That actually is not correct. Okay, when I do this in the calculator, I don't want to put I don't want to just enter this in, because 1.0 to the X is going to make this a B value of 1. Powers of 1 are just 1. That's going to kill it. I really do want to include this whole decimal here. Okay, so this is only an approximation right here. Now, the value of B, if I throw a little bit more information at it, the value of B I got was 1.0385 and so on. And remember what we did previously to determine the growth rate. What we did is if you subtract 1 from that, then what you're left with is a decimal approximation of the growth rate here. So now, if I round this to this right here, the nearest thousandth, I can tell you that the growth rate will be 3.9%, okay, when rounded. Now, the next 2 questions are asking, okay, what's the value of the ring in the 10th year, and in what year does it reach 13,000? Well, what I want to do is I want to do this graphically. I'm going to enter this into my y equals on the calculator. So here we go. Here's my regression. Now, the only way I can make this work is if the regression has already happened. Okay, you can't do what I'm about to do unless you've already done this step. So please make sure you do this first. Because once you've done this, the calculator enters that into this variable right here, the exp reg. Okay? So now, I'm going to come over here to my y1, and I want to pull out that equation here. I don't want to write down what I wrote down in the first step in this equation here, because I did do some rounding. I want the calculator to put the whole thing in there. So once I get here, just to remind you, I press vars, which takes me to a menu that looks like this. Okay, I am going to go down to statistics, because the thing that I did was a statistical operation, the regression equation. And the one that we're looking for is hidden in the EQ menu, the equation menu, regression equation. Press enter, and there's the whole thing to as many decimal places as I could get it. Now, before I graph this, I want to make sure that that plot is turned on. Now, in most cases, that's going to look like this. Okay? So I want to go up here and maybe just press enter to turn that on. Now, I know that I'm safe doing that because earlier in this lesson, I already set some of the parameters correct in my plot one. But just to review how to do that, you'd go second, y equals to get into your stat plot. Press enter to get in the first one. And what we want here is the scatter plot highlighted and list 1 and list 2. Okay, either way, from here, I could turn it on from the y equals menu as well. Just go up there, highlight it, press enter. Once that's highlighted, I can now press zoom number 9, and the calculator will choose window settings for me so that I can see my data. Okay, good. So now I've got a nice view of the data that I entered in there. There's the 4 points that I entered. Okay, let's take a look now what it's asking for. Determine the value of the ring in the 10th year. Okay, well now if I go to my window settings, notice my window settings, my max, my X max, and remember X is in terms of time here. My X max is giving me 3.3. Well, I need that to be more than 10 for this to make any kind of sense here. So I don't know, let's put 15 there. Why not? Give ourselves a little bit of breathing room there. Now, I suspect when I graph this, yeah, my graph shoots way, way up like that. Now, my graph is still thinking. I can stop it from thinking by pressing on. And what that does is that cuts the calculator from thinking through the whole thing here, because I know I'm not going to see the other part of it that I want to see. So go back to my zoom, my window settings. I need to increase my Y max. It's got to be way, way bigger than that. So let's make it, I don't know, it's going up really, really steeply here. Let's make it 50,000. See if that does it. Okay, well, I guess I was a little bit ambitious to think 50,000 was a good one. So I'm going to bring that back down again. I don't know, maybe what, half of that. Okay, so here we go. You know what, that's probably good enough. I could probably drop that down a little bit more, but there you go. It's just guess and check, okay? I'm just guessing at a value and adjusting it when I don't see it quite fit the graph the way I think it should. Now, the question is asking me, what is the value of the ring in the 10th year? So I know the 10th year. Years are the X variable here. So I'm going to press second, trace to get into my calc menu, and I'll choose the value operation here, the value function. Because when I press value, it's going to wait and let me enter in the X value. So I press 10, press enter, and it gives me that the ring is going to be worth $14,000. It looks like 64 cents. That's what I got. $14,000.64 when I round it to the nearest penny. Which doesn't exist anymore, but that was fun anyway. Now, the next question says, in what year will the ring reach $13,000? That value, that is a y coordinate on the graph. So to enter that in, I have to press y equals. And I'm going to come down to my second y equals, and I'll enter the 13,000 and graph it here. So now there's my 13,000 right there. So what I'm looking for is where these two graphs match up, where they meet. Because that's the instant, okay, that the ring becomes worth I think it's the ring. Yeah, it's a ring. Becomes worth $13,000. Now, go into your trace menu, your calc menu, so second calc, and I'm interested in where these two guys intersect, where they hit each other. Now, all I got to do is move the cursor there, the cursor relatively close to that point. Now, I'm going to move it, I'm going to pull it back just a little bit, just to show you what happens. It's on the first curve. It's asking, is this the first curve? It's blinking on it. You press enter to say yes. It will jump you immediately vertically to the second, to the y2. Now, is that the second equation that I wanted to work from? Yes. Press enter. It's going to ask you if it can use this as a guess, and the answer is yeah, sure. The guess is just designed to speed up the calculator. It doesn't matter. Press enter. Okay, and we get here, take a quick look, we get 8.037. I'm going to round it to right there. So the answer is 8.037. Okay, now, in what year did the ring reach this? Well, you might be tempted to think that this means the 8th year. But think about what's going on here. The way time is measured. I'm able to come down here. The way time is measured here. So say this is 1, 2, and this is out here. This is 3. Between 0 and 1, that is the first year. Okay, so 0.3 is still year 1, 0.5 is year 1, 0.7 is still year 1. As soon as you get to like 1.1, 1.2, which year am I in? Well, I'm in the second year. This is the second year. So now look at this. 8 represents the number of years that have passed, and we're 0.037. We're barely into it. But in what year did this occur? Okay, this occurred in the third year. Sorry, the ninth. What am I saying? Third year. I looked back up at the chart really quickly here. But this occurred in the 9th year. Okay, that's when that happened here. You got to understand the way the chart works. When the time starts, it's worth 9,600. At the instant of the first year being over, it's worth 9,960. But as soon as you're at 1.01, in terms of time, you're into the second year. When the second year ends, that's how much it's equal to. That's how you have to interpret that. So this happened in the 9th year.
Joe purchased a car and kept track of its black book value as shown below. Answer the questions related to this chart.
Okay, well this question isn't going to be very exciting, but it's fairly realistic here. We got a car and we're looking at the value of it. We're going to enter these values into our calculator and watch how this car loses its value. So first of all, we press Stat, Edit to get into the lists here, and we're going to clear the list. So clear, enter. Now in this case right here, I don't have to clear this because if I look at the data here, especially my x-coordinates, I got 0, 1, 2, 3, 4. Really what I want to do is just add a 4 to my list here. So I'll just go down to the bottom, press 4, enter, and I'm done. Okay, now those are the values in list 2. So 27,650, 21,912. So there it is. It's dropping in value. 18,200, 16,609, and then 15,162. Okay, so now we've got the data entered into the calculator. We're going to quit out of here. And we'll do a regression. So Stat, over to the calc menu, down to 0, at list 1, comma, list 2. All right, here's our regression. So it says write our regression equation. Now this time it doesn't tell us what to round to. So maybe what I'll do here, let's just take a look at the B value. I'll round to the nearest hundredth. We're talking about money anyway, so rounding to the nearest hundredth makes sense. Okay, so I'll make sure you can see this here. So I'm going to get Y, the cost here is going to be 26,130.81. Now the B value will be 0.86, 0.86 to the power of x. So there's our regression equation. Now, what is the rate of depreciation? Okay, remember that's when we take our B value. We'll take our entire B value here, so the 0.8625 blah blah blah. Okay, and I'm going to subtract 1 from that. So just point 8, actually, I'll tell you what, let's do this. Vars, I'm going to go down to statistics. You're going to like this. I'm going to go down to statistics. I'm going to go over equation, and look what's in number 3 there. There's B. There's the base there. So if I press enter here, I'm going to subtract 1 from that base. There's my depreciation. Okay? So when I subtracted 1 from it, I can see right now that I'm losing 13.7%. Okay, so just to reiterate what I did here, when you do the regression, the calculator figures out the A and the B value here. I know that my rate of depreciation is going to be the B value minus 1. To get that, I press, VARS. You go down to statistics, because that's where that equation is. You go over to EQ, but this time I don't want the regression. This time I want the piece of it, and there it is right there, B. Minus 1, and that tells you what that loss is. We're losing 13.7%. Okay. Now, estimate the number of years it will take for the value to be less than 7,000. Okay, so we're going to graph this. So I go to y equals. Okay, remember this is the information from the previous question, so I'm going to get rid of those. To put the equation here, I will go vars, down to statistics, again over to EQ, and this time I want that first one, the regression equation, so there it is. I want to find out the first time, or in what year, the number of years it will take for the value to be less than 7,000. So I'll put 7,000 here. This is my y coordinate. Okay, now I don't know. I'm going to make sure my plot 1 is turned on. I'm going to let the calculator choose the window settings to start off with, and then I'll adjust it to fit the data that I've got here. So I'll press, now that plot 1 is turned on, I'll press zoom number 9. And now notice how the regression equation, the function there, doesn't hit all the points. Okay? And I don't even see 7,000 being drawn here. So I got to go to my window. Notice that my y min, the minimum value was 13,000. Well, I want it to be substantially lower than that. I want to be able to see 7,000. So let's maybe put, let's put 5,000 there as my minimum. Okay, let's graph that. Oh, now look at this. That 7,000 there is way, way down here. I'm going to need to extend this graph a lot more to the right to make that work here. So my x max has got to be bigger than 4. Let's make it 10, see what that does. So here we come. Okay, good. So I see a point of intersection there. Excellent. So now let's go find that. So I press second, trace to get into this menu. Then I'm looking for my intersection. Is the cursor on the first curve? Yep, press enter. Did it jump to the second curve that I'm interested in? Yep, press enter. Can it make this as a guess? Sure, knock yourself out. Boom, there we go. And what do we get as our x coordinate? We get 8.907. So this happened, okay, at 8.907, so 8.91. So estimate the number of years. Now, this happened in what year? If it's 8.91, this happened, once again, we're going to round that up, this happened in the 9th year. So this took 9 years to get to this point right here. Now, in this case here, when it says, like, estimate the number of years, you probably would round that, okay? So, like, if this was 8.1, it took you about 8 years. It took you a little bit more than 8 years, so it took you roughly 8 years. This one was 8.9. Wow, that's almost 9 years. So you're going to round that to 9 years, okay? So it happened at the 9th year. In this case, rounding to the nearest would make sense. In the previous question when that happened, it said, in what year did that occur? No, it didn't make sense to round that way. You needed to round up. Now, how much will it be worth in 10 years at this rate? Okay, so with this, we're going to go back to our calculator here. Now, when I go to my window, I maybe want to give myself a little bit more leeway there because I had my x max at 10. So let's maybe make that 12, just so that 10 is within the function. Let's graph that. Oops, forgot about the 7,000. That's okay. It's okay, it doesn't matter. So now I will go, I want to figure out how much it's worth at the 10-year mark. So I'll go second calc to get into my menu here, and I'll press use value because I already know what year I'm looking at, and I want 10. And so the cursor is on the blue graph, that's important. Okay, at year 10, the value is, take a quick look at that, 5955.76. So 5,955.76 cents. Okay, so there you go. I hope that helps clarify that. We're going to do one more question.
Answer the following questions about this chart that shows global population in billions over a 40-year period.
Okay, so before we jump into entering these numbers in here, we might want to second guess a little bit what we're doing here. We've got the year 1970, and notice that we're given the population in billions here. Now, to enter this into your calculator, although it is totally okay to enter 1970 into the x-coordinate, 1980 into the x-coordinate, and maybe convert this into billions and write 391000000, and do it like that. We probably want to get a little bit more clever with this. It would probably make more sense to think of this as years after 1970. In which case this first one would be 0, 10, 20, 30, and 40. And then for me, just leave this as 3.91, 4.52, and just understand that those numbers represent billions. Okay, so now we're going to determine the exponential regression equation. So we're going to go in. First of all, we've got to enter in the data. So stat edit. Okay, there's already data in there. Okay, but I'm going to change this because my data is not quite correct. And I'm just going to overwrite it this time. Here's something else you can do. You can simply write over top of the data. So 0, that's a 10, 20, 30, 40. And then for my population, we had 3.91, 4.52, 5.22, 6.03, 6.97. Remembering that those are all supposed to represent billions. Okay? Now, we will quit. We want to create the regression equation, so we'll press stat. We'll move over to the calc, and then we're going down to 0, the exponential regression. Remember, list 1 comma list 2. Okay, here we go. And so now our equation is going to be y equals 3.91. There's my a value. Let's go to the nearest hundredth here, 0.1 to the x. Okay. Now it says determine the growth rate. So now what I want to do is I want to do my my little cheat here. I'm going to do the b value minus 1. Now I'm going to do it, but I mean the truth is I can see what that is right there. But I'll show you how to do it again here. We press stat. Oh, sorry, not stat. Sorry, vars. The vars button. Go to statistics. Over to EQ, and there's our b. And I'll subtract 1 from that. And so here's what we're left with. 0.0145. And so what this amounts to here is just under 1.5%. Okay, now so I'm going to round that to the nearest tenth of a percent here. So our growth rate is 1.5%. Now the next question says determine its population in 2020. Okay, so what we're going to do is we're going to graph it. Okay, I've already got data in there, so I'm going to get rid of these equations, just like we did before. So you press clear on both of those. Now, to get my equation there, once again, once I'm in y equals, I'll press vars, down to statistics, over to EQ, choose it, and there's the whole equation. My plot one is turned on. I already know that the scatter plot is on there. X list is L1, Y list is L2. Everything is correct in there. So if I press zoom, number 9 for zoom stat, it'll choose window settings for me that I will then adjust as I need them. So there we go. And actually that's a pretty darn good regression there. Now, we want to determine the population in 2020. So let's take a look at the window settings. I need this to go up to what here? Well, 2010 was 40. So I need this to go up to 50. My graph doesn't. It goes up to 44. So let's change this. I don't know. Let's make this 55. Give myself a little bit of leeway here. And there we go. Now the calculator, the graph quickly goes off the screen. Now, but it goes off the screen vertically. That's not a problem for me. If it goes off the screen horizontally, if the part that I'm looking for is out here, that's not good. But if it's above the graph, that's actually not so bad. So I'm going to go into my trace menu. So second calc to get me into my trace menu. Sorry, second trace to get me to my calc menu is what I meant to say. Choose the value feature, and I will enter 50. And now the calculator shouldn't have a problem with this because 50 is within the domain, okay, of this image here. And when I do that, I get 8.051. So 8.05 billion. Okay, is the way they're using the numbers here. Now, in what year will the population reach 10 billion? Okay, now they're giving us a y coordinate again, so we're going to go into our y equals down here, and we'll enter 10. Oh, I don't even see it. It must be my window. So I go into my window and I look, oh yeah, the y max here is nowhere near 10. So I need to change that. Let's maybe put 12 in there just to give it a little bit of extra. Let's graph that, see what it looks like. Oh, and they don't intersect on the screen here. Now, just to illustrate the problem here, if I was to go into my calc menu and go for intersect right now, and say, yes, I'm on the first curve, yes, I'm on the second curve, and it's going to ask to guess. Now, watch what happens when I let it go. I get an error. It's not that they don't intersect. The problem is they're not intersecting on the screen. So what I need to do here is make this X max a little bit bigger. I don't know, let's make it 65. Okay, go back to the graph here. We'll see if that's enough. Oh, just barely at the end there. Now let's just see if that's enough for the calculator to catch it. Sorry, we're looking for, yeah, intersect here. 1, 2, 3. Oh yeah, pass the guess. No sign change. So what that probably tells me is that my window settings weren't quite enough. It might even be right at 65 here, but we'll make this a little bit bigger. Let's make that 70. Okay, now they certainly overlap there. So second calc, let's get my menu there, intersect, yes, 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 and here we go. They're intersecting at 65. Well, just a hair over 65, but to a really, really small degree there. In what year will the population reach 10 billion? Well, 65 years past 1970, right? So what do we get there? It looks like it's going to happen in the year. Now, okay, I'm going to be a little bit anal about this. 2035. That is 65 years later. Now, if you looked at your calculator, that actually happened when it was 65 point something. Now, I believe this is the intention because the decimal was so small there, over. I believe this is what they were looking for. However, at the instant that 2035, at the instant it started, okay, or sorry, at the, well, it depends on how this, at the end of that year, that's when the population was 10 billion. It took just slightly into it. So I would argue that that actually should be 2036. That's just me though. Okay. Because it was so close, I suspect that the intention was that hit it right at the last moment there.